All right, well, my camera cut off unexpectedly. So this is 7.3 part 2. I had just finished example 5, and I was about to go into example 6. All right, so example 6, we are given this. Now, the instructions are so unclear. Analyze, well, it does this on his examples where there's not really any instruction other than to analyze something. But at the very least, we want to graph it, and we want to ask those, answer any questions related to the graph. So the process, we've kind of seen this before. We take the x, well, they didn't even do it here, and put them together. So take this term and this term and put them next to each other. 9x squared plus 18x. Take those two terms and put them next to each other. Y squared minus 4y. And then put this 4 on the other side, negative 4. So I would like this step a little better if these were switched around, is all I'm saying here. All right. What if I had that 9x next to this 18x? I can see that I can factor out a 9. And I'm not really doing anything here, just wrapping parentheses around there. And then what do I want to do? Well, now remember, this one isn't here right now until I put it there. So let's, I don't know, cover it up. All of these numbers are not in this original problem. But by completing the square, I know what to put here. I take the 2 and cut it in half and square it. I take the 4, cut it in half and square it. So it should be obvious why I'm putting this 1 here to get this perfect square. And I'm putting that 4 here to get this perfect square. But let's analyze what I did. By putting a 1 inside these parentheses, I added 9 times 1 on this side. So I need to add 9 on this side. This one times that 9, add 9. This 4 isn't multiplied by anything, and nothing in these parentheses are multiplied by anything. There's no number here. So just add, what you see, a 4 here, you put a 4 there. Now, a lot of times I can tell students do this wrong because they'll think that if they added a 1, they should add 1. Now, technically, you added 1 times 9, so you need to add 9. Those 4's cancel, I get this. All right, well, so I completed the square, yeah. But maybe, and by the way, maybe prior to this I didn't realize it was going to be an ellipse. But once you complete the square, if this 9 weren't there, it would be a circle, right? X minus h squared, y minus k squared equals r squared. But because this number right here, what I want is a 1. So divide everything by 9. You'll get x plus 1 squared over 1 squared. I can always put in a 1 squared just to make it look more like a regular function, a regular equation of an ellipse, or the standard equation of an ellipse. And I'm even going to mess with this and call that 9 3 squared because that makes it highly graphable. All right, so they do all of this analysis. I'm going to come back to the analysis. No, don't do that. Do you remember what our HK was just by looking at it? H is -1. So remember, it's x minus h, and you're looking at x plus 1. So match it up. H is -1. I said -1. I didn't draw -1. K is 2. What am I subtracting from y? Pretty obvious. I'm subtracting 2. So K is equal to 2. So -1 comma 2 is the center. Maybe I shouldn't call it C for center because C is a measurement here, but it is the center. What was my number under here was 1, right? And y minus k squared over, and I can change that to 16. What I'm doing is I'm just taking what I had, a couple of steps before and writing it here. All right, so along the x-axis, I'm going to move 1 to find these points. And along the y-axis, I'm going to go 3 to find the vertices, because that was the longer travel to go up 1, 2, 3. Those get status of the vertex. These aren't vertices. They're just interesting points. Actually, sometimes they're called the minor vertices, but our book doesn't use that. All right, the foci. Well, remember this was x minus h squared. I'm calling it x minus h squared because I don't really need the actual numbers here. So this is my a squared minus b squared equals c. 9 minus 1 equals, c squared. 8 equals c squared. So c is equal plus or minus the square root of 8, which simplifies to plus or minus 2 square root of 2. All right, so what did they do? They added 2 square root of 2 and subtracted 2 square root of 2 from this ordered pair. And since you're adding 2, you're just changing the y value. I'm not changing the x value. I'm not moving it left or right. Just changing the y values by getting those points. So, all right, we have the graph. We had the graph quite a long time ago, but we not only have the graph, but we have the foci, we have the entire thing. All right, I should let you see what they're what they're doing here. I don't know. They're using something like this. I have a name for it. I call it a boutique formula. It's like, yeah, if you were programming a computer to find the vertex, this formula works, I guess. H, comma, and what are they doing? They're adding A to K. H, comma, K. Here's K is 2. They're adding it to find the vertex. I'm really not a fan of these formulas. I mean, they're great if you're programming a computer, and some of you do that. Some of you are computer science majors. They work for that, but everything we're doing here with these formulas is better done on paper with you actually drawing it. So actually just start drawing. I'm really disappointed that the drawing didn't have the center in it, because it kind of makes it much harder to really make sense out of, this being the point, and I go up C to reach the vertex. And I guess I'll say that. So A is never a surprise because it comes from the equation. It comes right out from the 9. This is a squared, so a is 3. So 3 in each direction. B is pretty clear. Well, this original problem didn't have a denominator because it was 1, but I like to think of it as being clear. If I just, am forced to put a number here, it would be 1. So it's 1 in this direction. That's B. What's not clear is C, and that's kind of a recurring theme here. You actually have to calculate that. It's one of those invisible values. There's no C. So I think I said this a long time ago, one of my earlier videos, is there's a type of question I don't like. And it's when somebody stabs at something like this, and says, I can see the A, it's A squared is 9, so A is 3. And I can see the B. B squared is 1, so B is 1. But how do you know C, right? And they just keep on pointing here. How to C? How do I find C? Well, I don't know either. I mean, I don't see it here. You're asking me to tell you how to find something that's invisible without you doing the work. And that's not a good question. It's not a good thing to do. You need to substitute in the proper equation, and C will pop out. C will calculate it. In other words, don't point to something invisible and ask me how to find it. Point to something visible and find it there. I mean, make it visible. That's our job. Our job is to do that calculation. I'll roll this back even further when someone says, hey, you know what? My tutor told me A was 9 and B was 1. And then they're looking up here. How do you know A was 9? I feel like saying, I didn't. Next question, right? I didn't know A was 9 until I was able to put it in a format where that had B and A in it, right? Match it up. I didn't know A was 9 until I got to this point in the process. So, a good question would be, how do I do this process? That's fine. But kind of a silly question to start asking about something that isn't visible, right? Stick to the process and we'll get there. All right, that was just my 2 cents at the end. And that is what we're going to do. We don't really have any other types of problems in this, but, it ties up a lot of stuff in this section with the foci and the vertex and things like that. And that is section 7.3.